Okay, let us take a look at topical practice 3, whereby we are given two functions, f and g, with their equations and their domain. So part 1 asks us to sketch the graph of f and states its range. Okay, so you may want to use GC to help you determine the shape of the graph for f. Okay, in general, it should look something like this, whereby the maximum point is also at the y-intercept, coordinate 0, 1. So the range, you just take a look at all the possible y values which the graph can take. So for the range, right, you see only this portion along the y-axis whereby there is the graph. So only this portion. So my range of f would be above 0 up to 1. Okay, including 1. That's why I have a square bracket over here. Okay, part B asks us to state the largest possible domain for which f is a 1, 1 function. Okay, so if you recall, what do we mean by 1, 1 function? Basically, it means we can use horizontal line test to show. So for example, if we draw the horizontal line test now, say I draw over here, it cuts the graph at 2 points. So it is not 1, 1. That's why we need to determine what is the largest possible of a. Okay, we want the interval in the form x less than or equals to a. That is from negative infinity to a certain value such that my graph will be 1, 1. Okay, so let me use this black rectangle as an illustration. Okay, so as we shrink the domain of the graph, okay, becomes smaller and smaller. Okay, now it is still not 1, 1. Okay, because I draw a horizontal line, you will cut at 2 points. Okay, it's still not 1, 1. Only when my x is less than or equals to 0, then you can see I will only have this curve left. And if you draw a horizontal line, then you'll see that it cuts exactly once, no matter which horizontal line you draw within the range. Okay, anything more than 0, okay, if you, let's say I shift a bit more, okay, anything more than 0, you'll see that, if I draw a horizontal line, it will still cut at more than 1 point. So in this case, okay, my largest value of a is 0. Okay, the next thing we want to do is to define the inverse function. Take note, from part 2 onwards, okay, the domain of f is no longer the whole real line, but rather the domain of f is now minus infinity to 0, because we are going to talk about inverse, and this is the domain that the question wants, such that the inverse exists. So let us find the inverse function. So we can write let y equals to 1 over 1 plus x squared, and the whole idea of inverse is to make x the subject. Okay, so what I can do is I can bring up the 1 plus x squared is equals to 1 over y, and x squared is equals to 1 over y minus 1. And from here, take note, there are two solutions to this: the positive square roots or the negative square roots. Now, many students make the mistake. They only thought that the solution is only the positive square root. They forgot about the negative square root. Now, in this case, we are talking about inverse. We are talking about 1, 1 function. one x should only have one equation, but in this case we have two different equations for x. Therefore, we need to reject one of the equation. Which equation you reject? You take a look at what is the condition for x. So in this case, we will look at the condition for x. We say that x can only take negative values and 0. Therefore, we have to reject the positive square root. And when you write rejected, please state the reason. X must be less than or equals to 0. Okay, therefore my F inverse, we have this expression, negative 1 over x minus 1. And recall what is the domain of F inverse, which is equals to the range of F under this domain. So if you refer to the previous slide, the domain would be 0 to 1. Now the last part is asking us to check, does GF inverse exist or not? Okay, so for GF inverse to exist, take note, this is my first function, this is my second function. So what is the condition? The range of the first function must be a subset of the domain of the second function. In other words, you should check what is the range of F inverse. Is it a subset of the domain of G? Then you need to recall the range of F inverse is actually the same as domain of F. And from part 2 onwards, we say the domain of F is actually from minus infinity to 0. And what is the domain of G? Is equals to the whole real line exclude 1. Therefore, the range of F inverse is a subset of the domain of G. Hence, GF inverse exists. Now the very last part we want to find is the range of GF inverse. So what we can do is, let us try to find the equation for GF inverse, which is the same as G over F inverse X, okay, which is equals to 1 over the equation for F inverse, okay, minus 1. And take note, whenever we are talking about function, we need to take care of the domain. So in this case, the domain of the composite function is the same as the domain of the first function. So this is the same as domain of F inverse, which is equals to 0 to 1. So in your GC, you should be sketching this curve under this domain before we look at the range. So if you use your GC, okay, I'm just sketching a rough shape. You should look something like this, whereby the value here is minus 1. Now I put a hollow circle at the origin because the equation of GF inverse is undefined when x equals 0. Okay, so from GC, the range of GF inverse, okay, is equals to negative 1 to 0, excluding 0.